Hi, children. This is really a difficult, or I can say different kind of question. I'll say difficult only when the children are seeing it for the first time. So ultimately, they have to think what has to be done. So if you have not seen it before, so I don't know, can you make out what has to be done here? It's given to you that x cos alpha is equal to y cos alpha plus 2 pi upon 3 is equal to z into alpha plus 4 pi upon 3. This is given to you, and we have to find out the value of x, y, y, z, z, x, right? So normally we think somehow we should get the value of x, we will put it here, we will put the value of y, z, then we will calculate. We cannot do any question randomly. Anything can be done and we will get the answer. Maths is not like that. We have to proceed in particular way so we can reach the proper answer. So here, if I need the value of xy plus yz plus zx. So we have to think differently. First of all, if these three expressions are given to be equal, so we can assume all of them, let it be k, right? First of all, I'm going to take this only, x cos alpha, y cos alpha plus 2 pi upon 3, z alpha plus 4 pi by 3, that is equal to k. Okay. Now from here, if I take the value of x, it will give me, you equate first term to k, second term to k, third term to k, and from there we are going to get the values of x, right? So x is k upon cos alpha, y would be k upon cos alpha plus 2 pi upon 3, z is equal to k upon, this is cos of, this is cos is missing here, please write down, cos of alpha plus 4 pi upon 3, again cos of alpha plus 4 pi upon 3, so z will become k upon cos of alpha plus 4 pi upon 3. So you must be thinking ki now we have got the value of x, y, z, so let's put it there. You're not going to get anything, right? And you're going to make it so complicated, because if you will put x k upon cos alpha, y ka value k cos alpha plus 2 pi upon 3, then what else you can do here after putting the values? You will get k into k square, right? That's going to make it very, very complicated. So we cannot proceed like that. Ki directly putting the values of x, y, z will not help you at all. So what else can be done? Right, because I told you normally we are using half angles formula most of the times. If I say that half angle formula is applicable, then you will say in multiplication that is not possible. Then what we will do, see, from here I'm going to get the value of 1 upon x. How half angle formulas can be made applicable? Now you will see here, I have taken 1 upon x. Obviously I have to take the reciprocal of this, so ultimately cos alpha will go in the numerator. Similarly, from here 1 upon y will become cos of alpha plus 2 pi by 3 upon k. K will come in the denominator. 1 upon z will become cos of alpha plus 4 pi by 3 upon k, right? Now what else we should do? Because I told you that we cannot put the values of x, y, z directly in this given expression. I'm starting differently. If I add 1 upon x, 1 upon y, 1 upon z, then what will happen? We will be able to apply half angle formula. Now you can see that if I'm going to add these three expressions, 1 upon k will come out to be common. Now what we will have, cos alpha plus 2 pi by 3 plus cos alpha plus 4 pi by 3. Okay, so did you see that how we have just turned the question in something else, right? And now you again must be surprised ki how we are going to get xy plus yz plus zx by taking the sum of 1 by x plus 1 by y plus 1 by z. You will see very easily we are going to get that. How? First of all, I'm going to use cos A plus cos B formula in the last two expressions. I'm going to keep cos alpha as it is. Cos A plus cos B, you know that what is that? 2 cos A plus B by 2. 2 cos A plus B. This is A, this is B upon 2. That will give you 2 alpha 2 pi by 3, 4 pi by 3, that is 6 pi by 3. 6 pi by 3 will become 2 pi upon 2. Now cos a minus b, if a minus b, alpha and alpha would be cancelled. 2 pi upon 3 minus 4 pi upon 3 will give you minus 2 pi by 3. And cos minus the theta is cos theta. So this would be written as cos of, this is minus 2 pi by 3 upon 2, that would be minus pi by 3. So after that, this will become 1 upon k cos alpha. Now from here, 2 would be cancelled, and we know that pi plus alpha, third quadrant. I hope you know that. Pi plus alpha, this is pi, then we are adding some acute angle, it will lie in the third quadrant, and in third quadrant cos is negative. Okay, so we will write this as 2 times cos of, this is alpha, and that minus sign I am replacing this plus sign, and that minus I'll write here. I hope you understood how that minus sign has come. Now, cos minus pi by 3 would be written as cos pi by 3, because I told you cos of minus the theta is cos theta. And because here children do this mistake, very common, because cos minus theta, most of the children, they write minus outside. This happens only with minus, sine minus theta, minus sine theta, and it happens with tan also, but not with cos. Remember this. Okay. So by using this, I can write 1 upon k cos alpha minus 2 cos alpha cos pi by 3 cos 60. That is half. 2 got cancelled. Cos alpha, that has become 0 to 0. Again, now how we are going to get the value of this expression xy plus yz plus zx? We are going to take LCM here, because 1 upon x, 1 upon y. So did you see how the twist has come? Right, how we started, because sometimes just directly putting the values never help you. We have to start differently. Okay, if I take, because this has come out to be 0. Now if you take the LCM here, it will give you x, y, z in the denominator. Then we are going to have y, z, x, z, x, y. This is 0, and we know that this is 0. It means, I mean, the whole thing is 0. It means that if you cross multiply, so x, y, y, z, z, x. So did you see how different question was this? I hope you have understood. Keep checking the coming up videos, because I'm going to take all sort of important above average hot question. Thank you, beta.